Most RAG teams are logging the wrong thing, and that is why bad answers survive in production.
Exactly. People save the final prompt and the model output, then act surprised when they cannot explain a miss. In RAG, the failure usually starts earlier, in retrieval and context assembly.
So if I am building a RAG stack, what is the minimum useful trail? Not dashboards, not vibes, the actual forensic record.
Start with retrieval. For every query, log the user query text, a normalized query if you rewrite it, the embedding model version, the retriever type, top K, filters, index version, and latency. Then for each retrieved chunk, log document ID, chunk ID, source URI, title or section, chunk text hash, rank, score, and whether it came from dense, sparse, re-rank, or fallback retrieval.
That sounds like overkill, until the day ranking shifts, and nobody knows why.
Right. Concrete case. Yesterday, a policy answer was correct. Today, it cites an outdated handbook. If you logged index version and chunk text hash, you can see whether retrieval pulled an old chunk, whether chunking changed, or whether a query rewrite widened the search too much.
And if you did not log those fields?
Then, every team starts guessing. Search blames generation. Generation blames source docs. Product blames users. Logging decides who is right.
Okay, retrieval is one battlefield. What about the context that actually reaches the model?
Log the assembled context, not just the raw candidates. That means the ordered list of included chunks, their IDs, any truncation that happened, token counts per chunk, total context tokens, separators, deduping decisions, and the exact instruction block used to frame the context.
Because two systems can retrieve the same chunks and still produce different answers if context packing changes.
Exactly. Example, chunk 3 has the key exception, but your packer cuts it off when a long preamble consumes the budget. If you only log retrieved candidates, you will swear retrieval worked. If you log final assembled context and token budget decisions, you see the real bug in minutes.
Now prompts. A lot of teams are nervous about logging them because prompts are messy, dynamic, and sometimes sensitive.
Still log the structure. Store prompt template ID, template version, system prompt, developer instructions, user message, tool instructions if any, placeholders after rendering, and generation settings like model name, temperature, max tokens, stop sequences, and seed when available. If privacy matters, redact secrets, but do not destroy the shape of the prompt.
So the point is reproducibility, not collecting every character for sport.
Yes, you want to replay the exact state that produced the answer. Example, a harmless template edit changes one line from answer only from context to answer using context when helpful. Suddenly, hallucinations rise. Without template versioning in logs, that regression looks random.
Let us get to the end of the chain. What answer fields matter besides the answer text itself?
Log, the final answer text, refusal or uncertainty flags, finish reason, output token count, latency, any tool calls, post-processing steps, and a confidence signal if your system computes one. Then log citations as first-class data, cited document IDs, chunk IDs, quote expands if you support them, citation positions in the answer, and whether each citation was actually present in the supplied context.
That last one is brutal, because a citation can look polished and still be fake.
Exactly. Example, the answer says section 4.2, but section 4.2 was never retrieved. If your logs track citation to context alignment, you can catch fabricated references automatically, instead of waiting for a customer to notice.
I want one practical debugging flow, something a programmer can run when support drops a ticket saying this answer is wrong.
Start at the answer and walk backward. First, inspect the cited chunks. Were they actually in context? If no, it is a generation or citation formatting bug. If yes, check whether the cited chunks truly support the claim. If no, retrieval ranking or source quality is at fault. Then compare retrieved candidates versus assembled context. If the right chunk was retrieved but excluded or truncated, context packing is the bug. If the right chunk was never retrieved, inspect query rewrite, filters, retriever settings, and index version.
Give me a real scenario, not a diagram.
A user asks, Can contractors access customer export data? The system answers yes and cites the security manual. Logs show the correct policy chunk was retrieved at rank 7 with a strong score, but top K was reduced from 10 to 5 during a latency optimization. The answer used an older chunk that discussed internal staff, not contractors. That is not an LLM mystery. That is one config change with a measurable blast radius.
So winners and losers here are simple. Teams with logs fix the issue in an hour. Teams without logs spend a week arguing in Slack.
And the stakes are bigger than speed. Poor logs let silent regressions ship. Good logs let you evaluate every stage separately. Retrieval quality, context quality, prompt quality, and answer grounding.
What about volume? If I log everything forever, storage explodes.
Use tiers. Keep full debug traces for sampled traffic, failures, and high-value queries. Keep compact metadata for the rest, but never drop the join keys. Request ID, session ID, query ID, retrieval IDs, chunk IDs, prompt version, and model version. Without join keys, your data is just rubble.
So the clean mental model is 4 layers: retrieval, assembled context, prompt construction, answer with citations.
Yes, and each layer needs versions, IDs, timing, and enough content to replay what happened. That is how you stop treating RAG failures like magic tricks.
Which means the log is not paperwork. It is your chain of custody.
Exactly. In RAG, the best team is not the one with the fanciest model. It is the one that can prove where the answer came from, where it went wrong, and how to fix it fast.